So this question is asking us to write the molecular ionic and net ionic equations for the reaction between KOH, potassium hydroxide, and H2SO3, which is sulfurous acid. So let's start by writing out the molecular equation. KOH and H2SO3 are going to react. Now, this is similar to a precipitation reaction. It's a kind of double replacement reaction. The K is going to pair up with the SO3. Now, K plus is a +1, sulfite is a -2, so on the other side you would expect to get K2SO3. Now, most things with potassium are soluble. Actually, everything is, so we assume that's an AQ. This is what we call a salt in this kind of reaction, SALT. Now the other product would be hydrogen hooking up with hydroxide, and that gives you water, which many neutralization reactions, as this one, gives you water, and we'd write water as a liquid. And so in order to figure out what the balanced molecular equation is, we would need to go and just do some quick balancing. I need to put a 2 in front of the KOH and also a 2 in front of the water. And this is what we would call the molecular equation. Now, we next need to go to the ionic equation. And in this case, we've got to be a little bit more careful. With precipitation reactions, it was always, anything, we said that all soluble ionic compounds that had AQ after them would dissociate. But in this case, we've got to think about acids and even some bases, but really acids. KOH is a strong ionic compound. It's a strong base. So we would show that as being dissociated into 2 Ks and 2 hydroxides. But the trick is that H2SO3, sulfurous acid, is a weak acid. And so weak acids are not shown as being dissociated. They are not dissociated. And so we actually have to leave that alone as H2SO3. So just because it's aqueous does not mean that it's going to dissociate. Now on the other side, K2SO3, since potassium compounds are soluble, I will show that as being dissociated. I get 2 potassiums out of the process, so I should put a 2 in front of that potassium. Liquids are also not shown as being dissociated. So I would show the 2 waters as being still together. And so then when I go on to the net ionic equation, I would cancel out spectators. And so in this case, if I look at the spectators, potassium is the same on both sides, but nothing else is. So the net ionic would be 2 hydroxides reacting with sulfurous acid to make sulfite ions and 2 waters in their liquid state. So that's the net ionic equation right there.